Hey guys, so in this video we are going to talk about a fundamental skill that we're going to use all year long and is going to make our lives a lot easier if we practice it now. And that is the skill of converting between units, specifically between metric units, doing what's called metric conversions. So you should be taking notes for this video on your handout for today and also using those notes to do the practice problems that will follow. You can also reference them in the future whenever you need to do more practice problems because you'll have them on this handout. So, firstly, the metric conversions. These are based on conversions between units in the metric system. We've covered what these units are already, but I'm going to briefly go over them together. So let's say you wanted to measure the length of something, how long something is. What do you use? Well, the units that you use to measure the length of something are called meters, which we abbreviate with a lowercase m. If you wanted to measure how heavy something is, its mass, the units for the mass of something are grams, which we abbreviate with a lowercase g. And last but not least, if we want to measure the volume of something, which is how much space an object takes up, basically how big it is, the units that we use for volume are called liters, and we abbreviate that with a capital L. Now, in some situations, liters or grams or meters are not going to be the appropriate unit to use. We need to use something different, something that's either smaller or bigger. So for example, let's think about if I was saying, okay, here's Richmond, and we want to know how far Richmond is down to Oakland. You would not tell me how far Richmond is in inches, for example, because it would be so many inches between the two cities. You would tell me how far it is in miles, because miles are bigger and it's a more appropriate distance to use. The same thing happens with grams and meters and liters. We have to use the unit that's appropriate for the distance or length or mass or volume that we're measuring. So the way that we convert between units are using something called conversion factors. So I've listed a bunch here. These are the conversion factors for length. These are the conversion factors for mass. And these are the conversion factors for volume. Okay? You don't have to copy all these down right now, but I would just recommend taking notes on the video that we're going to use because you will always have these when we're doing a problem. Each one of these is a relationship. So let's look at this example right here that says 1 kilometer, km, equals 1,000 meters. This is a relationship between kilometers and meters. Just like we know that in 1 foot there are 12 inches, in 1 kilometer that's the same thing as 1,000 meters. So we can write any relationship like this in the form of a fraction, where we put one of the units on top. So let's just put 1 kilometer, km, on top, and 1,000 meters on the bottom. We can do that with any one of these. So for example, with mass, I could take this relationship and I could write this as a conversion factor. Remember, this is just a fancy word for a fraction. And I would write that as 1 gram over 1,000 milligrams. Now, ratios can also be written the opposite direction. This is the same thing as 1,000 milligrams over 1 gram. And this one is the same thing as 1,000 meters per 1 kilometer. You might be thinking, why is it important to be able to write it in both ways? Well, as we'll see, it depends on the problem. It depends on what we're given and what we're trying to solve for. So let's go ahead and just do some practice problems together because that will make things a lot easier. Okay, so at the top here I have all of my conversion factors ready in case I need to use them. Let's look at this problem. What does this problem say? The problem says the new school that we're in, and I took a picture off the internet of it right here, is 15.4 meters tall. How tall is this in centimeters? So what we want to do in every problem is circle our given. Our given is going to be the number. So our given is equal to the number. We want to circle it. And underline our unknown. Our unknown is what the problem is asking for. It's saying, how tall is this in centimeters? Okay, so once I've done that, the first step is to always write down my given. So my given was 15.4 meters. So I'm going to write that first. 15.4 meters. But I'm trying to convert to centimeters. So what I need to do is I need to look at my chart up above here, and I need to find where is the relationship between centimeters and meters. Okay. Well, if I look, I'll see here that 1 meter is the same thing as 100 centimeters. So what I need to do is I need to write that as a fraction. So there's two ways that I could write this as a fraction. I'm going to do them down below right here. I could write this as 1 meter over 100 centimeters, or I could write it as 100 centimeters over 1 meter. I need to decide what I want to use based on what's given to me in the problem. What's given to me is 15.4 meters. So to do a conversion, I'm going to draw what I'm calling train tracks here, where this line basically just represents multiplication. And in the denominator, on the bottom here, I need to have the same units that I have in the numerator on this step. So since I have meters here, on the bottom I need to have meters. So out of these two relationships, which one has meters on the bottom? This one does. So I'm going to take that conversion factor and I'm just going to plug it in over here. I'm going to put 100 centimeters over 1 meter. And I'll cross this off just to make it clear. Why did I want to do that? Well, now, since I have the same units on the top and the bottom, those units cancel out. Meters cancels with meters. So what I'm left with, if I draw an equal sign, the only units that are left are centimeters, which is what I'm trying to solve for. So now to actually do the math, what I need to do is I write 15.4 times 100. I take everything across the top and multiply it together, and divide it by everything across the bottom, which is just 1. So 15.4 times 100 over 1, that's the same thing as 115,440. Okay? Units, centimeters. There is my final answer. How can I check if I'm right? Well, the first thing is if the units in the numerator are the units that the problem is asking for, you know you have enough steps. Then if your units cancel from the top and the bottom, you know you're also doing the right thing. The last step is to do the math. So that might have felt a little overwhelming at first. Let's go ahead and do 3 more practice problems very similar to this. So this problem says, the average bag of hot Cheetos weighs 86 grams. How heavy is this in mg? So first thing, circle my given, 86 grams. I'm just going to write the G up here to make it clear. And what's my unknown? How heavy is this in milligrams? Okay, I got to find that relationship between grams and milligrams in my chart. So where is it? I need grams and milligrams. Here we go. 1 gram is the same thing as 1,000 milligrams. Okay, so I'm ready to go. I want to write this as fractions. I can write this as 1 gram over 1,000 milligrams, or I could write this as 1,000 milligrams over 1 gram. Let's see which one I'm going to need. So start by writing my given. My given was 86 grams. Okay, so now what am I going to put on the next step? Well, since I have grams in the top here, I need grams in the bottom. Which of these conversion factors has grams in the bottom? This one does. So I'm going to write 1,000 milligrams over 1 gram. How do I know that that's right? There's 2 ways to check. Are the units in the top, the numerator, what the problem is asking for? I have milligrams in the top. The problem is asking for milligrams. Do the other units cancel? Yes, because I have grams in the numerator and grams in the denominator. So that means all I'm going to do is 86 times 1,000 divided by 1. So that's going to come out to 86,000 milligrams. That's my final answer. One thing I want to point out, this is saying that 86,000 milligrams is the same thing as 86 grams. I'm just representing it in a different unit. Just like I could say that 1 foot, like we talked earlier, is 12 inches. I'm just using different units to represent the same amount. Let's go ahead and do another problem. An average soccer ball has a volume of 1584 cl. So I'm going to circle my given. What is this volume in liters? That's my unknown. So I need centiliters and liters. Let's go and find that in the chart. There it is. 100 centiliters equals 1 liter. So let's go ahead and do this problem. Might be a little bit faster now. It's our third time. 1584 centiliters is my given. So in the bottom, I need to have centiliters so that it will cancel out. So out of this relationship, the fraction I'm going to need on the bottom is 100 centiliters, and on the top, 1 liter. How does that work? Well, I have liters as my unknown. I have liters at the top, so that's good. Check. Here, centiliters cancels with centiliters, so that's good. Check. So I'm left with 1584 times 1. That's everything on the top, divided by 1,000. So what does that come out to? Excuse me, not 1,000, 100. So that comes out to 1584 divided by 100, which is the same thing as 15.84 liters. Boom. Let's do one more problem, and this one you should be able to do on your own. The heart of a human weighs 1.8 kilograms, kg, given. How heavy is this in grams? Unknown. So I need the relationship between kilograms and grams. There it is. Okay, let's start with my given, 1.8 kilograms. So in the bottom of the next step, I need kilograms. Okay, here's the relationship. 1 kilogram is the same thing as 1,000 grams. So I'm going to cancel kilograms and kilograms. 1.8 times 1,000 divided by 1. 1.8 times 1,000, 1800 grams is my final answer. Now, there will be some challenge problems after these practice ones that I give you. And if you want to do the challenge problems, my hint would be to compare numbers. The units must be the same. So for example, if I said, which is heavier? 12 grams or 1.2 kilograms. You can't just compare the numbers because the units are not the same. You have kilograms and grams here. So you might have to do a conversion before you do those problems. So now that you've watched this video, you should be able to do one-step conversion problems with the metric system. Remember, always circle your given, underline your unknown, find the conversion factor in the chart, make sure the units match up in the numerator and denominator so they cancel, make sure the units in the top are what the problem is asking for, multiply all the way across the top and across the bottom, and don't forget your units at the end, and then you've done conversions. So after this, go ahead and work on the practice problems in your packet for today.